Hello and welcome to Maths with Jacob. This lesson will focus on differentiation part 2. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. Differentiation from first principles. Consider the above curve, which has an equation of y equals function x. That's the blue curve here. If we remember from earlier work, the slope is the difference of the y values over the difference of the x values. We've done that many times. Let's look at the point P here, which has coordinates x, function x. Here they are here. And the point Q, which has coordinates x plus h, so from there to there is x plus h, so the y value must be function x plus h. And then we form this triangle here, see that one there? So basically the slope of this red line here will be the vertical rise over the horizontal run, or the difference of the y values over the difference of the x values. So basically the difference of the y values is function x plus h, which is this one, minus function x, which is that there, so it's that y value minus that y value, over that x value minus that x value, so it's x plus h minus x, which is function x plus h minus function x over h. The above represents the gradient of the line PQ for any curve y equals function x. In order to find the gradient of the curve at the point P, we need to make h very small. So if we're looking at the gradient of this blue curve here at that point, that is the gradient of the tangent at that point, we have to make h very, very small so it approaches the point P. So, if we look at the limit as h approaches 0, so h becomes very, very small, of function x plus h minus function x over h, if we look at that, we can find the exact gradient of the curve at P. This is known as differentiation from first principles. And we did the work on limits earlier, so we understand what's going on here. So this is very important. It's called differentiation from first principles. Let's continue this on the next slide. Let's look at the example of this sketch here, and let's assume that it is the sketch of function x equals x squared. Furthermore, let us apply the differentiation formula and find the slope of the graph at any point P from first principles. Now P can be anywhere on this graph. We're going to find the slope of this graph at that point. From the previous slide, let us calculate the limit of function x plus h minus function x over h as h approaches 0 for function x equals x squared. So function x plus h is that. You just put x plus h wherever you see x. Function x, that's already x squared, over h. We simplify the numerator. The denominator is still h. So we simplify the numerator again. That gives us 2xh plus h squared. We factorise to get to this line. We cancel the h's out. And that gives us the limit of 2x plus h as h approaches 0, and the limit is 2x. So that is the gradient of the point P. Wherever P is on that curve there, the slope is 2x. And that's been calculated from first principles. So, the derivative or gradient can be found from first principles. In the next video, we will look at how to find the derivative of many functions using some simple procedures which will give us the answers very quickly. Now here's a simple convention. There are three very simple ways we can use to show that we want to find the derivative, or if we want to differentiate. The first one is dy dx. You'll see that very often. The second one is function dashed x, or the third one is y dashed. So those three there, any one of those can be used to let us know that we want to differentiate because we're looking for the gradient. So the above three notations are widely used and they are all highly acceptable. Let's finish off by differentiating a more involved function from first principles. Let's assume that function x equals x squared plus 2x plus 5, and we want to find this limit here. So we substitute function x plus h into there, and that gives us all up to there, up to the 5. So we put in x plus h wherever we see x, and there's our 5. Minus function x, which is there, divided by h. We remove the grouping symbols, and that gives us the numerator. We simplify, so from there to there, we just simplify. Now we use some brackets, so we do some factorising with the brackets. So we factorise. After that, we cancel the two h's out. So that gives us the limit of 2x plus 2 plus h as h approaches 0. So when h approaches 0, the answer is 2x plus 2. And that has differentiated this expression here, or that function, from first principles to obtain 2x plus 2. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle. What is the meaning of the following? Big fish in a small pond. That's very, very easy. I think you can see that. Here is the answer to the quick quiz, and the video is at your disposal.